This is Electric Universe Geology Earth News. Today we're going to look at a formation west of Farmington, New Mexico, east of Shiprock, New Mexico. This is it here. It's a really cool looking hogback that runs down along here with the river going right through it. There's a scale. This is almost 2 miles, maybe 1.5 miles across. And there's a road right here so you can stand here and see the hogback itself really clearly, see all the layers. Let me zoom in a little bit. The way I see things, my warped version of things, you'd have wind coming from the east here. You'll see what I'm talking about in a minute. Let me bring this down. Better size if I can. Should have never started messing around with that. Anyway, the wind seems to have been from the east. Windward is on the east side. Leeward is on the west. These are little baby hogbacks with the same layering as the east side of the major formation. So these are like little tiny winds. I interpret this as this was wet, so it wasn't able to accumulate while this was growing its base. So you don't have the base material over here that you do underneath of this, but the very top layers that are the most lithified on the right hand side, on the east side, are the same layers that you have over here. I have photographs that will show this. And then it starts again over here, and there's a small drainage that goes through here that I don't think eroded this. I think it prevented this. There were two drainages, one here, one here. They hook back up over here. But that's why there's no hogback here. So let's look at the photographs now. So this is the east side of the hogback. Here are the layers, which I think would be the last ones to be deposited, with the wind coming from the east. It's either that or this was lying flat with all these layers underneath of it flat, and then it folded up, exposing the west side or the left side. Some of these layers in here, I'm not sure exactly which, but some of them, according to a local geologist, are coal, which is extremely common to find within these hogbacks. It seems to be part of the deal. So now let's look at the west side of the formation. This is the west side of the formation. To me, these layers mimic the very eastern layers on the larger formation, the last ones to be laid down. These look very similar to the last layers of the larger formation, except you don't have the beginning part of the formation, the softer, less consolidated material under here. During that part of the deposition process, I believe this was probably underwater, so it did not accumulate. It probably dried out, so that at the end, when you had the lithified material coming down, you have the same trending back towards the east. I hope this makes some kind of sense. So you can't tell it from looking at these pictures, but I almost froze taking them. It was so cold. It was January after the EU conference in Albuquerque in January. It was just freezing. So yeah, my friend and I suffered to get these shots. Anyway, this is not unusual. These hogbacks are everywhere. Let me show you a map of some more. This is just real quick to give you a feel for where we've been. The first picture I took, I was standing here looking this way. This is the windward side. These would be the last layers laid down. This is the second area I photographed, where everything is also trending to the right, to the east, but it's only the lithified layers from this area that seem to be replicated here. There's less consolidated material down here that I think was coming in, while everything else was flooded. The flood probably came to right here, which is why it started there, started building back. But then you get hotter, more molten material making those last layers up here, which are replicated down there. So now let's look at a different location. These are the Black Hills, South Dakota. There appears to be a hogback going all the way around. Over here it's a little bit tougher to see, but I've read about it. And it appears as if the wind was coming in all the way around it as if this was some sort of a vortex with material being pulled in towards the center, creating hogbacks that trend away from the center. I'd like to go there and look at it for myself and see what this area over here looks like, but this is quite obvious that there's a hogback trending away. Now we're back in Colorado. Here's the eastern slope. There's a hogback trending to the right. To the east, it comes all the way down. You have the grand hogback here that trends generally towards the west, generally speaking. I don't know what causes these, whether it's the low area and whether it's below the flood, but there's situations where that doesn't seem to hold up. Let's go back to what we were looking at earlier. The question is, why is this here in such a sinuous manner? Is it a filament? Why is this hogback in this location? Why is the grand hogback where it is? Why do these things happen where we find them? They're not always at high points. There are places in California where you have flat mesas covered with basalt, with gold underneath, with humans and toys and tools and all sorts of things, and they're not at a high point. I'll do a video on one of those shortly. So there's a lot of questions with these hogbacks, a lot of things that aren't answered, which I kind of like. Thanks.